Hello, good morning. I am going to present my progress report for today. So I will start with the data integration and summary. So what I did here is I gathered all of the Word files containing the collection data in different weeks. It also contains the length and weight of the shrimps. So what I did here is to integrate it or transfer it into a single file as shown here, and I sorted it into different into the pond number, the site, the collection date. And in order for me to visualize the data and also to easily know the maximum and the minimum value of the data, so I need to plot some graph and charts here. So I started with the length and versus the age of the shrimp. This is the data, so you can see the distribution of the data. And I also plotted the weight versus the length of the data. So from the graph, you can easily see the gap in the data. So at certain time, we have skipped some of the data collection activities during these growth times of the shrimp. So we don't have data on those parts. However, if we look at the weight and the length relationship, we can see a certain pattern, and it represents a certain curve. So I did some further data analysis using curve fitting, using the exponential, polynomial, and the power functions there. So it shows the equation as well as the r-squared value. So here the r-squared value represents how fit is our regression curve to the actual data, or how good is our curve. So a higher value of the r, or an r-squared value close to 1, means that it is a good curve fitting or estimate to our actual data. So here the power function has the value that is close to 1. It has a value of 0.925, and it's also the polynomial function also has a closer r-squared value to 1, which is 0.921. So there's just a little difference between the two. So this means that these two curves here has a good estimate of the weight given a certain length of the shrimps. However, in the exponential function, at the higher length or higher part, it has a big deviation, higher deviation. So another is, I also made data analysis using the A and N. So I used, other than those functions, I also used A and N and made some parameter experimentation on the different hidden neurons of the A and N. So here I just showed three plots or graphs or charts rather, because these are the only ones that showed successful results. Other runs of mine resulted to a non-convergence of the data, and this is also one of my problem. So here, if we have tuned hidden neurons, I got higher, a very high error, about 282. But with 3 hidden neurons, the error got lower. However, it's not the same with 4 hidden neurons, which produced about 10,000 error. So the error is very large. So I still have to check other parameters like these steps. So I have to adjust the number of steps that the algorithm needs to take. So the 2 charts show that the steps are very high in order to obtain a lower error, while with 4 hidden neurons, it only has a few steps, but the error is very large. So the steps is the number of adjustments that the ANN needs to perform during the training stage. So one of the problem is the neural network performance in R using the data is very, very slow. So it sometimes took me about 30 minutes just to run these neural networks. Although there are some other runs which just took a few minutes. So this is one of my concern. The algorithm does not converge always to good results. That's why I did a few parameter experimentation. So here, what I try to plan to do for my next progress is to continue on parameter experimentation and to look for ways to improve the performance of the algorithm in R or maybe in some other tools that still implements ANN. So that's all for my progress report for today. If you have questions, you can write your comments in this video or raise your questions during my presentation time. Thank you.